So someone wanted to know about if the vision is actually inverted in the retina and the cortex, then how can it be correctly oriented when we're actually looking at the world? And that is true. So when you're looking at like a person here with your eye, this image actually is like this on your retina. And what happens is your cortex just turns it upside down. And interesting experiments have been done with this phenomenon where people have been given prism glasses which do the opposite, invert the image. And what happens is when you have that prism in your glasses, if you wear it for 48 hours or so, the whole world will be inverted, but then after a while the cortex will put it back. And that's not the interesting part about the experiment. The interesting part of the experiment is when they took off the glasses, the whole world was upside down for a few days, and then it went back to normal. What's amazing about the experiment is, how did you know it was going to go back to normal? Wouldn't that be terrible if it didn't go back to normal? So the short answer to the question, is it inverted on the retina? Yes. Is it inverted when it goes to the cortex? Yes. How does it go back to normal? Cortex puts it back in the right orientation. And that's actually not surprising because the cortex does a whole bunch of other things to you, and I'll just mention some so that you know it's not confined to this. So you know when you have a visual field that you have a blind spot that's right there. And that blind spot represents the insertion of the optic nerve because the photoreceptors are not present on the optic nerve head. And even if I tell you you have this blind spot and you cover one eye, it won't appear in your visual field. And that's because your cortex just fills in the physiologic blind spot, which is an absolute scotoma. There literally is no vision there. And so even knowing that information, you can't make your blind spot appear. The other way that this cortical event occurs that is interesting is saccadic suppression. So you know when you look at something quickly between, let's say, the right and the left, you're looking at target X versus target Y, you actually see this big blur on your retina when you look from target X to target Y. But when you saccade, you actually don't notice that big blur. You only see target X and target Y. And that's because your brain just turned all of this on. The last thing I'll tell you that you do that you don't know you're doing is your blood vessels actually are blocking the photoreceptors because the blood vessels live right under the nerve fiber layer, and that's on top of the photoreceptor layer. So really, you have an imprint of your blood vessels on your entire world, but your brain just subtracts that whole thing out. And that is amazing as well. And if you've ever seen those color confusion illusions on the internet, you know that two people can look at the exact same dress and claim that it's white and blue or gold and blue when we know the exact wavelength that is coming off of that picture. We can measure the wavelength, and yet there's all this dispute about it. That is called cortical. And if you ever watched the movie The Matrix, you know that your whole world could be the Matrix. And that's how that's inverted.